Let U be this n-dimensional vector field where Rn is the n-dimensional Euclidean space. And this is the divergence operator, which contains partial derivatives with respect to x1, partial derivative with respect to x2, and the partial derivative up to partial derivative with respect to xn. The first questions, we would like to show that the divergence of U, the vector field U, is equal to the sum of the first partial derivatives of each component of the vector field. And the second question is the following. We have U, which is x1 to the cubed, x2 cubed, xn cubed, and we would like to show that the divergence of this vector field is 3 times the little L2 norm of x squared. We pay attention to the first question. The divergence of U equals, we use this nabla operator. We take the dot product. This is partial derivative with respect to x1, partial derivative with respect to x2, partial derivative with respect to xn, dot product, u1 component, u2 component, up to un component. What is that? Is the partial derivative of the first component plus the partial derivative of the second component up to the partial derivative of the nth component with respect to xn. And this is the sum j equals 1 to n, partial derivative of the uj with respect to xj. Divergence of u equals to the sum from n equals 1 and the partial derivative of each component with respect to xj. We proceed to the second question. The n-dimensional vector field is the following. So u equals x1 cubed, x2 cubed, xn cubed. The divergence of this vector field is the following dot product. Partial derivative of x1 cubed with respect to x1 plus the partial derivative with respect to x2 of the x2 cubed plus the partial derivative of xn cubed with respect to xn. This is 3x1 squared plus 3x2 squared plus 3xn squared. We can take 3 to be the common factor in this case. And inside the brackets we have x1 squared plus x2 squared plus xn squared. This can be written as the square root of x1 squared plus x2 squared plus xn squared, and all of it to the power of 2. This is the L2 norm, the little L2 norm of x squared. We deduce that divergence of u equals 3 times the norm, the little L2 norm of x squared.